All the data is available in the description. So everything that we're going to discuss here is available there in the description. It goes without saying, but we really like it when all of you come back and say, okay, this channel is brilliant, we'll subscribe, or you like our video, or you comment on that. And so please like the video, definitely subscribe and put that bell marker on. We promise to put out tons of good content. We have a wonderful pipeline for YouTube for the next few months, and we've amped up our production values as well. It's taken us a lot of figuring out to do that, but we are amping it up every day, and so we should have quite a fun ride this year. Definitely do subscribe to our channel and spread the word about us. Hello guys, we're going to do a full round of kind of doing bunch of things with the data. And first of all, many thanks for all of you who have contributed data set for the 2iM website. We've taken one very simple decision that all the data we get, almost all the data we get will be shared. So there's a nice clickable link. You just look at the description, click there. You can download the entire data set and you can manipulate it any which way that you want. So keep that in mind. So it should be a lovely data rich project. Right? Now we've got 6,000 plus data sets, which is quite a lot. That should be enough, that should have been enough to do whatever inferences you want for our sample size, for our population size. Right? Having said that, our data is likely to be heavily biased. Keep that in mind. It's going to be heavily biased because the guys who are contributing the data are the ones who are clued in, who understand that they want to check out their performance, who are likely to have prepared, who go through different websites to check out their possible expected percentiles, potential scores, likely calls, all of that. And because of that, there's going to be a heavy bias towards higher quality candidates, higher numerical scores. And so keep that in mind. So the sample is large enough to make inferences, but it's likely to be heavily biased. Keep that in mind. And as I said, we have shared the entire data set. Click on that link. You'll be able to download a CSV or an Excel file or a Tableau file, whatever format works, and you'll be able to check out all the data. Those of you who are interested in data analytics, this is a brilliant opportunity for you to do different things with the data to see how you can make inferences. We're going to do a bunch of inferences. We will share that through this video and through our website and blog link. But those of you who can do more on that, please do that and drop us an email. If you can publish decent piece of research, we will publish it on our blog and give you credits for that. The best 3 research pieces will also get wonderful discounts on our online course. Lovely. So because our data set is heavily biased, we cannot make any inferences on the overall number. We cannot say this score will get this percentile. This is good. That is bad. This will get a call. That will not get a call. Those inferences we cannot make. And we will make judgments about that. We'll make a ballpark figures about that. We'll take it through and say, okay, maybe this is the range, but we cannot make credible data-led complete inferences about that. So what can we do? Why are we going through this exercise? We cannot answer the holy grail questions. We can definitely do wonderful comparison across slots. Slot 1, slot 2, slot 3, which was tougher, which section was tougher, that we can do. And that's got to be a very interesting idea to pick up on. We can definitely compare VARC, LRDI and Quant, which is a high scoring section, which is a tougher section, which is mixed, which has higher variance, all of that we can find. So we can also have a go at normalization. The normalization formula that they've given is very clear. It's beautiful. I actually originally thought the normalization would happen around the mean. It looks like they've done the normalization around mean plus standard deviation for whatever reason they are. I don't think I have the credibility to say we understand that formula completely and the reason behind it, the intuitive. We don't have it, but we have followed it to the T to say what the scores will be like. Right? Let's have some fun. Wonderful. So I'm going to start with what the data is telling us. So we got all data, we put it across slots and across sections. Right? So and we said we're finding the mean. That's interesting, and we will find the standard deviation as well. Right? So this is the starting point. It's a wonderful table. So anyone who wants to start, you should spend 5-10 minutes just staring at this table, because if you look at this mean and this mean and this mean, there's a very clear, brilliant inference sitting right there. And so you just have a good look at this. This table alone is sufficient to give a sense of relative difficulty levels. Right? This comparison can tell us which section is the higher scoring section and in which slot. The other number which we found interesting was standard deviation. And standard deviation is the level of volatility of a sample. So if a sample has average of 40, the 40 can come by saying 40, 40, 40, 40, 40, or it can come 20, 60, 10, 70, 0, 80. Both averages will be 40. The first one is a steady sample, so standard deviation will be very low. Second one is a volatile sample, standard deviation will be high. It looks like standard deviation is slightly higher, but standard deviation vis-a-vis the mean comparison is meaningful only across different exams or different years. So it looks like it's high, but we can't make any inferences beyond that. The inferences regarding slots and sections, we're going to make them. So have a look at this table. Those of you who want to do something with the data, this is your starting step. Okay? Lovely. So let's make those inferences. Let's see how this works. Okay? What we've done here, we've taken all VARC data and said, let's take slot 1, slot 2, and slot 3 and then plot them. So what we did, we plotted them in terms of in equivalent of a percentile. This percentile, remember, it's a clear caveat, this percentile number has nothing to do with the exam percentile. This is a percentile ranking based on the sample space that we have. So the number of items that we have, we put this. So completely forget about this. Don't look at this number and this percentile and think this is a percentile corresponding to that score. It is not that. So what is it giving us? We've compared the 3 slots. What we said, we can compare across slots. If you look at this, it is very clear that this slot, so slot 1 VARC, is markedly below slot 2 and 3 VARC, or slot 1 VARC was noticeably tougher. And very clear, this is clearly tougher than this. So VARC, what inference can we make? The slot 1 VARC was noticeably tougher. Very clearly we can make that inference across different rankings, different data sets. It just jumps out. The data just, this chart just screams saying this line is tougher than these two. Okay? Likewise, let's do the same thing for LRDI. LRDI is the exact opposite. And slot 2 and 3 are literally on top of each other. Whereas slot 1 is, so the slot 1 marks in LRDI are on average across the board higher than the marks for slot 2 and 3, or LRDI slot 1 was simpler. In an ideal scenario, the guys who have conducted the exam would have wanted all 3 charts to collapse onto each other, meaning there is no variance across slots in terms of level of difficulty for each section. That's the ideal scenario. Otherwise, normalization does come into the picture. They have large data sets, so normalization should take care of it. But in an ideal scenario, you don't want too much of adjustment happening on account of normalization. So if whoever is conducting the exam, they should look at this chart and say all 3 should have been one on top of each other. That didn't happen. Section 1 was significantly tougher, slot 1 was significantly tougher in VARC, significantly easier in LRDI. Let's look at Quant. Quant, if you look at it, slots 1 and 2 are literally on top of each other. There's a green line and the purple line. Slot 3 is higher, or slot 3 Quant was tougher, was easier than the other two. Right? So this is slightly anomalous. I won't say counterintuitive because we didn't have any basis for making that comment. But I don't know if you guys remember, on the day of the exam, almost everyone was saying, look, CAT was really tough, slot 3 was obscenely tough. If you look at it, the data is clearly saying, if anything, slot 3 was the easiest. I'm not saying slot 3 was easy. I took slot 3, I found it tough. But the data is saying it was still easier than the other two. The VARC in slot 1 was a nightmare. And the Quant in slot 3 was easier. The Quant in slot 3, quite a few of us actually felt no great shakes. It was not that difficult. But we all arrived at Quant after having been slaughtered in VARC and LRDI. Therefore, you're conditioned to, you're tired and you're conditioned to thinking that's also tough. And so the Quant in slot 3, the data is telling us that at an overall level, Quant slot 3 is easier than slot 1 and 2 Quant. And so we've seen how these sections at this point. Now, the other thing is looking at all 3 slots and then thinking about Quant, LRDI and VARC. We all tend to think that there's a perception out there that Quant is the big elephant in the room as far as preparation is concerned. It's going to be the section that is vast and where it is likely to be high scoring as well. But if you look at the data, the LRDI is tough, no doubt about it. LRDI is below the other two. So that is probably the least scoring section. But between VARC and Quant, for the vast majority of students, VARC is the one that contributes more marks. So if you're looking for higher marks, it's likely to come from VARC contribution. Right? Now, somewhere along the last bit, the last leg, Quant overtakes. This again ties in with the other hypothesis that we have, that there are few people in our country, or a few thousand, who are really good at Quant, who know their math, for whom the CAT Quant is not challenging or obscenely tough as much as it is a time management thing. And so there are going to be a sizable number of people from, say, the NITs or IITs who know their math, who therefore find cat quant reasonably doable. For them, it's just a question of how much they can amp up and how few errors they can make, how quickly they can do stuff, all of that. Because of that brigade, probably Quant overtakes VARC in the last leg. So Quant is likely to be the highest scoring section for the guys in the top 1-2%. After that, VARC is a high scoring section. So the takeaway for me in this is don't have your preparation plan completely biased towards Quant. That's a mistake great many people do. You just keep going to town over Quant. You need to know the basics. You need to understand basic arithmetic. Make sure you keep your head above water, and then think about the other two sections as well, definitely, because the syllabus topic-wise Quant is vast. So Quant can completely dominate your mind and completely let you forget that it's only 1/3 of the paper, and it's quite likely that you get less than 1/3 of your overall score from there. So keep that in mind. Slots comparison. Slots 1, 2 and 3. If you look at this, 1 and 2 are almost at the same level. 3 is simpler. I'm having a big grin on my face because I took slot 3 and we came at the end of the exam, we said, look, slot 3 is so tough. We'll all be big beneficiaries from normalization. So my mark is worth 5% more. None of that is holding good. If anything, the normalization for slot 3 is going to work the other way around. We're reasonably sure of this data. We've had a large enough sample. We've done a lot of this chunk with normalization. VARC slot 1 tougher for sure. LRDI slot 1 easier for sure. Quant slot 3 easier for sure. These 3 inferences, I think the data is just screaming out. Therefore, if you put all of them together and add up the marks, Quant 3 appears to have been the easiest of the 3 sections, which is dramatically opposite of what we originally thought. So that's something to chew on for listening to YouTube videos at the end of the session. Nobody has taken all 3 sessions. It's obvious. But therefore, you finish the exam and a couple of hours later, a bunch of people come out and say, my slot was toughest. Nobody has enough credibility to actually make that claim. And quite a few of us did it. I'm not saying this is a major crime, but we need to keep in mind that people are making analysis and inferences based on a 2-hour experience and extrapolating based on the several other experiences they've heard of in the other 2 sets is not likely to be right. So we need to be calmer and say, okay, I heard this, but there's no basis to say this has to be true. So you take everything with a pinch of salt. Right? Wonderful. So how is normalization going to work? Normalization, the algorithm is brilliant. So the formula they have is brilliant. I don't completely understand the intuitive basis for it, why they've applied that, but it's nice. You go through it and you plug it in and then you see the numbers. The normalization, the way it works, completely marries with the charts. And so if you had to have a gut feel based normalization for different numbers and you said, look, this should go there, this should go there. Then if you had a look at what the numbers are saying, they're similar. So the formula it works. So anyone who's saying normalization is humbug or it does not do justice, I don't think that's called for the size of the data set they have. I think the exam generally gets normalization right. They should not have to resort to it. The exam level of difficulty should be more or less on top of each other across the 3 slots. But if they have to, I think they do a decent job. So looking at slot 1, the one thing, the inference that we made very clearly was slot 1 VARCs was tougher. So 46 goes to a 49.8, 33 goes to a 37.7, 18 goes to a 23.7. This is what we got from our numbers by plugging in and religiously following the formula that they have given. The LRDI gets marked down. 47 becomes 41.9, 39 becomes 33.9. Everything gets marked down. Quant gets marked up because slot 3 quant was easier than the other 2. On a relative basis, slot 1 was tougher than slot 2. These 2 get marked up. This sharply, this mildly, that gets marked down. The net impact for slot 1 is likely to be higher. And a couple of things about this table. These scores are the actual scores of candidate that we have picked up. Fine. So someone has scored 46, 47 and 27, adding up to a 120. It should, if I'm doing the math, it should work. So 46 plus 47 plus 27 does indeed add up to 120. And then the 3 normalized numbers add up to this. Now remember, this normalization, anyone who scored 46, it will become 49.8. This will work, this will work. Anyone who scored 120, it will not automatically become 121.5 because the 120 can happen as 46, 47 and 27. It can happen as 40, 40, 40. A 40, 40, 40 will get normalized differently and this need not be 121.5. So if you're looking to find your normalized score, you should plug in to VARC, Quant and DILR and then add it up. There's no basis for normalizing at the overall level. So something to keep in mind. Each section we amp up and then add it there. So a 120 in slot, all 120s of slot 1 are not going to be 121.5. There are different 120s sitting inside this, something to just keep in mind. Let's go to slot 2. How does the normalization look here? The VARC gets marked down because slot 1 was much tougher. So slot 2 is relatively easier. So the score gets marked down. LRDI gets marked up because slot 1 was easier. DILR gets marked up. And Quant also gets marked up because slot 3 was easier in Quant. In LRDI, slot 1 was easier. So slot 2, overall, we're seeing that the benefit of normalization is reasonably present across the board. And so slot 1 and slot 2, both, I think the scores will get amped up a little bit thanks to normalization. Once again, I'd like to remind that this 120 is not 128.3. What is sitting underneath that 120 will drive what it becomes. And so let's look at slot 3. Obviously, slot 3 should step down. If you look at slot 3 VARC, it gets marked down. Slot 1 VARC was toughest. LRDI gets marked up because slot 1 was easier. Quant gets marked down. The Quant marked down in slot 3 is going to be sharp because it was easier than the other two. Right? So therefore, this marking down, those will offset those. We have scores coming down in slot 3 post normalization. Again, if you're looking to get your normalized score, look up on each of these tables based on your slot score, get the corresponding normalized ones, then add them up to get there. Don't look at this table. What is sitting inside a 120 is very crucial to figuring out how your normalization will be. Right? Wonderful. So normalization, we've had a go at. We've got a sense of that. Now what do we do? All of this is fine and dandy, but finally we're all looking to say, okay, I put in this score, I want to know where my percentile is. Straight away, I'm going to tell you that we've done this predominantly as an academic exercise, as a fun exercise, and not as a predictor tool. So we're not going to plug it in and say you have this much, because we are playing around still with a sample. It's a sizable sample which have made quite a few adjustments, but it's a sample and it's a very heavily biased sample. So somewhere along the line, we'll have to say, this is our judgment. We think this will be 99th percentile, or we think this will be 95th percentile. We will make that, but we'll put 100 caveats and say clearly that it's a judgment driven thing and not a data driven thing. I want to make that distinction very clear. And so, but still we are all curious to know that. Fine. So when we thought that, we said, let's not worry about the percentile number, but we know we can do slot 1, slot 2, slot 3, or VARC, LRDI, Quant comparisons much better. So what we did was, we arranged each of these scores in descending order, whatever sample we have, and then we compared that with the overall. So what do I mean by that? These three scores do not add up to this score. The overall score in descending order looks like this. The highest one, VARC score in descending orders look like this. Quant looks like this. Sorry, LRDI looks like this. And so if you find any one point here and checked out the 4 numbers, then the corresponding percentile for a given percentile, for the total score, LRDI score, Quant score and VARC score, we can match that out. What do I mean by that? If you can say that someone who's got 80 marks totally in overall stands at X percentile, then for that 80, you can find corresponding VARC, LRDI and Quant. You can make very credible inferences about the 10,000th rank in LRDI will correspond to the 10,000, and the corresponding scores for the 10,000th rank to Quant, corresponding score for 10,000th rank in VARC, 10,000th rank overall, that we can make. So we can bring all 4 descending orders in sync. Whether that will correspond to 10,000th or 6,000th or 11,000, that we cannot make. That inference we cannot make. Fine. So this chart puts each of these in descending order. Straight away, you should have to remember that if you take the 10,000th rank VARC, LRDI and Quant and add that all up, that will not correspond to the 10,000th rank overall. It will become a much better rank. And so if you add these 3 data points, it won't correspond to this. And so we basically said, let's forget about the number to the percentile. We'll link all of this up. For a given rank, we don't know what that rank is. We know each of these. Why is that useful? Is that if you can have a reasonable gut feel for any one, then you can make very credible inferences about the other 3. If you're reasonably sure about, okay, where is the total line going to lie, then you can make inferences about VARC, LRDI and Quant, which is what we have done. This last slide, we're going to have a stab at that. Again, even before I go into that, I can tell you that so far, we listened to the data. We said this is what the data is saying. Here, we're adding a layer of judgment. based on how biased our sample could be. What is the bias sitting inside the sample? So keep that in mind. Okay. So what are we saying? So we're saying if you get a total of 100 marks, ballpark there, then your percentile is likely to be between 98.75 and 99.25. The ballpark of 99 percentile, a total of 100 marks. Now, this 100 mark is kind of normalized. That means it might correspond to a 98 in slot 1 and 101.5 in slot 3. So look at those tables, make that adjustment, get your normalized score, and then have a look here. This number should be indicated. And just remember, so the 98.75 to 99.25 percentile in VARC could be 39, could be 34 for LRDI, could be 43 for Quant, 100 overall. Remember, straight away we can see that if you add these three, it doesn't add up to that. We're not saying a student has scored this. That's not what you're saying. The 99th percentile, thereabouts overall score is 100. Thereabouts VRC score is 39. Somewhere there LRDI score is 34. Somewhere there Quant score is 43 for 99th percentile. So we've got even higher in each of these, it will go higher up and it will go to the higher ranges there as well. Right? So what is it? So if the total is not 100 but 90, where does that put us? A total of 90 puts us in the 96.5 to 97.5 range, and percentile wise. So this range will be fetched by a 35 VARC, a 29 LRDI, a 37 Quant. Another thing to remember, a 35 VARC, here the normalization impact could be higher because we're going to the section level. A 35 VARC, a 27, 28 in slot 1 probably automatically means a 35 normalized score. Whereas the 38, 39 in slot 3 become 35. So keep that in mind. These are kind of normalized numbers. Again, once again, just repeating, these three need not add up to this. We're trying to say that for this percentile range, this score is what is roughly likely to be. So if we get 80 marks overall, you're likely to be between 94 to 96. This is a normalized score. So make that adjustment slot wise. And for 94 to 96 percentile, a VARC of 32, a LRDI of 25, a Quant of 32 will fetch a percentile like this. Right? So what is the other crucial number, that 80th percentile number? Thereabouts. That will be 20 in VARC, 14 LRDI, 17 QA. A 20 in VARC, slot 1 of 15 could fetch a 20 of VARC. So if you're in slot 1 and you're very worried about 80th percentile, then probably 15, 16 should be all right as far as VARC is concerned. Fine. So again, once again, it's a caveat. This is where we're adding a layer of judgment. We're basically saying this, we're confident about this linkage. 100, whatever rank that is, that will be same as 39 in VARC, 34 in LRDI, 43 in Quant. That part, not worried. Up and down a little bit, not worried. But saying 100 corresponds to this percentile, a little bit of judgment and an assumption on which way our sample is biased is being used. So keep that in mind. That's about it as far as the data presentation is concerned. Please look at the description. There's a wonderful link there where you can click and get the entire data set, where you can download the entire data and do all kinds of analysis for yourself. All of these tables are shared on our own website, so you can go through them. Anyone who's interested in kind of doing different things with the data and coming up with wonderful inferences, please have a stab. So and if you find some interesting insight and you want to share it, send us an email. All our contact details are available on the description. We will publish the best research pieces and we will offer wonderful discounts for the guys who have taken the time to take the data and do that. Fine. So we've been hearing for so long that data is going to drive everything. Fine. So and this is wonderful data for a nice, interesting exam. It's available on a transparent platform. So those of you who are saying, look, I love to take data and analyze, they don't give me raw data, here it is. It's your chance to take that raw data and have it. Final caveat, a lot of this is the slot comparison, within slot section comparison, those are all credible. The percentile predictions, one of the reasons why we've kept it like this and not plugged a number in there is to clearly say unequivocally that this is a guesstimate, not a prediction. So that is something for you also to keep in mind. Final thought, very often we want to see a 94.65. When you plug in your numbers, you want to see that number. The time from now till when results come out is going to be uncertain. It's going to be anxiety filled. It is what it is. There's no amount of going through this or any other exercise is going to give you anything concrete. And so set it aside, prepare for XIT, prepare for personal interviews. Those of you when I have a chance of getting a call, please start preparing for personal interviews. Start reading news in reasonable depth. Best wishes for your interviews. Best wishes for XAT, SNAP, IFT, all the exam. Cheers, guys. Please do get back in touch with us if you have any queries, doubts about this or the data or research publication. Best wishes.